please welcome with me Patrick Bareiszlig.
Thank you very much. My name is Patrick. I will talk about a threat-based security monitoring approach using the Mitre attack matrix. A little bit about myself. Can we see our you can't see our new beautiful pink, because earlier we were black and green, and now we have beautiful pink, but can't see it. Yeah, I am working as a senior security research engineer for Splunk. The research team of Splunk is working on detections, detection which can detect different types of attacks, and we are also working on a lot of tools around detection development. For example, we're working on attack simulation software where we are able to test our detections, and we are currently trying to integrate it into a CI pipeline, that this detection can be automatically tested. Before I was working for Airbus. In Airbus, I was a cybersecurity engineer developing the detection framework for Airbus. And I really like to work on open source projects. Here are a few of mine: Sigma to Splunk Alerts, Sigma to Sigma Hunting app, and I have plenty more of them. When you want to follow me on Twitter, here's my handle. I'm really like a fanboy of Iron Man. That's why I placed it exactly here. What we are talking about today. When we want to develop industry-tailored detection, this is quite a challenging task. Many companies don't have the money or don't have the people. When they have the money, they don't get the right people to do it. That's why today I want to show you how you can come from your industry to detections. And what I want to introduce a lot of open source detections. Detections which you don't have to develop by yourself. They are already out there. There are plenty of projects. Yes. The mapping from industry to detection is not possible directly. We will together map the industry to different APT groups, advanced persistent threats. Then we'll map this set of groups to a set of attack techniques, and then we'll try to find detections which are able to detect bad techniques using different data sources. Today in the talk, we'll have a fictional company with us which we try to protect. This is Evil Corp. Evil Corp owns 70% of the global consumer credit industry. They are targeted by a lot of advanced persistent threat groups. One group is F-Society. And who recognized the company? Shout out. Yes, say it? Exactly. It's from the TV show Mr. Robot. Mr. Robot is like a TV show directed by Sam Esmail. The main character is a cybersecurity engineer working for a managed security service provider, and in the evening he turns into a hacker and doing some bad things. Should definitely watch it. And let me introduce you Terry Colby. Terry Colby is the CTO of Evil Corp. He's a little bit not anymore up to date with the latest technology and IT security, but all of us know we have to make the boss happy, and he's our boss for the talk today. He will mention some things during the whole talk, and I think he already had something to say. He wants us today in this talk that we protect Evil Corp from advanced persistent threat. Advanced persistent threats are highly skilled, mostly state sponsors attacking groups. And as we all know, there's not like an easy APT scanner out there which detect all of that stuff, but let's try our best. The first thing what we try to do is now we try to map a specific industry to a list of APT groups. Resources which you can use for this mapping are on different cyber threat intelligence sources. One is, for example, FireEye. Who saw that page with all the different FireEye APT groups and who read through it? Raise your hand. Okay, probably more, but maybe it's late and you don't want to raise your hand anymore. Here we can see APT10. APT10 is also it's also called menu pass. One challenge for us as consumer of that data is that these different CTI providers like to use different names, like FireEye or Mandiant like to use the term APT. We'll see later Crowdstrike, they prefer to use animal names for their advanced persistent threat groups. Here we can see that they are operating out of China, and here we can get our information about which sectors they are targeting. You will see today a lot of automation. I'm a very lazy guy. I like to automate stuff, but this first mapping from industry to APT groups, I was not yet able to automate that. When somebody in the audience has an idea how to automate that step, please let me know. Then we have also other CTI providers. We have Crowdstrike. Crowdstrike likes to use animal names for the different APT groups. Like when you read a beer, then it's a Russian group. When you read when you see a panda, it's a Chinese group. Yeah, but we can also see here they list also their target sectors which we need for our first mapping. So, what we achieved now is we mapped industry to a list of APT groups. In our next step, we take this list and map it to attack techniques. Why do I want to use a technique or not another indicator? For that, I want to show David Bianco's pyramid of pain. Who saw that pyramid before? Yeah, quite a lot already. You see on the pyramid, you see different indicators, hash values, IP addresses, domain names, and on the right side, you see the pain which it's caused to the attacker when we can take away that indicator from the attacker. Let's start from the bottom. We have hash values. Changing a hash value for the attacker is so trivial that it's caused no pain to the attacker. Furthermore, we as attacker storing all that malicious hash values in a big database, this is not worth the time and the storage. Then we have IP addresses. IP addresses are like the most fundamental indicator which we can think of. But changing IP address of the attacker is quite easy. He's maybe behind an anonymous Tor proxy where you can easily change it, or you just switch to a lot of his other IP addresses which he has as malicious command and control service. This is easy. Then we have domain names. For domain names, it's starting to get a little bit more painful for the attacker because they also have to register it, they also have to pay for it. That's why when we take away one of that, it's getting a little bit painful for the attacker. Then we have network and host artifacts. Network artifacts are, for example, a specific URL pattern. When we see machine-generated URL patterns, which attackers likes to use, when we can take that away from them, then they have to change their tooling, they have to change their script. Or for example, host artifacts. Host artifacts are, for example, a registry run key, which you see in a Windows box for specific malware. When you're able to detect that, this is annoying for the attacker. Then, tools. Tools are normally either they develop it by themselves and they spend a lot of time in developing their tool, or they pay for, or they have to buy that tool for a lot of money, and when we are able to take away that tool, that is already quite challenging for the attackers, because they also have to get some money out of the operations, and when they have to change their tooling, this is quite it's quite expensive. And then probably you can't see it. There's the name on the pyramid on the top is like TTPs, tactics, techniques, and procedures, which means we don't want to, for example, we don't want to detect the reverse shell of tool X. We want to detect any reverse shell, which is going over on standard HTTP port. Who can imagine what kind of knowledge base we can use to identify the TTPs? Yes, Mitre attack matrix. The Mitre attack matrix is a knowledge base which consists of tactics and techniques. In comparison to the cyber kill chain, it's focused more on the post-compromised steps. Because we need to be honestly, when they work on their cyber weapon at home, we have no chance to detect it. Normally we are also not able to detect the exploitation phase, but we can detect what they're doing afterwards. When they lateral move through our environment, when they install malware, when they call out to their command and control server, or when they try to reach their objects, which is, for example, data exfiltration. The Mitre attack matrix, maybe you can't read it, it's a little bit small. You see here now two different kinds. You have tactics, which you see with a dark gray background. This is like the attackers, the adversaries' technical goals. For example, one technical goal is that he wants to establish a command and control channel in order to control the malware which is inside our company, in order to load stage 2, which lateral moves through the company. Then we have techniques. Techniques have a white background, and the techniques are the possibilities what an attacker can use to achieve this goal. For example, let's stay with the example command and control, which is like here. He can now use different possibilities to achieve that. He can use commonly used ports, which is HTTP, HTTPS, DNS, or he can use a proxy, have a lot of different possibilities. The Mitre attack matrix also provides us even more information. We can click on one technique, in this example the spear phishing link, which is very, very popular. Spear phishing is like some kind of targeting phishing, like a phishing mail which feels like that it's only written for you. And we see here a lot of information. We see a description, we see ID, tactics, platform, data sources. And here, this is very interesting for us today. You can see the different APT groups using that specific technique. In this case, it's APT 28, 29, and many more. Let's have an example. Who heard about the group Turla? It's not like the newest one. They are already operating since several years. They are operating out of Russia. Their target industries are mostly Western countries and governments. And they're developing most of their tools in-house by themselves. They're very advanced. And what we are able to read recently in the news is that they try to masquerade as an Iranian group for their hacking attacks. So, what we want to do now, we want to take that group and we want to identify all the used techniques by that group. And you can see it's quite a lot. We see again like our spear phishing. Spear phishing is very popular as an initial access because it's very successful. We people like to click on links. There's a link, oh let's click on it. Another link, oh let's click on it. Then we have execution. We see there PowerShell and scripting. We saw during DeepSec a lot of talks which talk about PowerShell and how we as defender can use it to automate stuff. But unfortunately the attackers, they are also as lazy as we are and they use PowerShell to automate their attacks. Which means PowerShell is one of the most used techniques in attacks and other scripting. Then what else? What is very interesting is then for, where is it? For credential access? Yeah. Normally we heard a lot about credential dumping using mimikatz, but this group used a lot to search for credential in files. Who never stored any password in a file? Please raise your hand. All of us did it already one time. Even maybe it was only for a few hours. Sometimes it was a little bit longer for a few hours. But searching for credential in files are quite easy to get more passwords, to move laterally, very stealthy. Yes. So this is now the mapping of one single group. Unfortunately, life is not like this, that only this group is attacking this company and this group is only attacking this company. There are normally a bunch of APT groups attacking us. Oh, that's beautiful. You see here now that this should be a dark red. And you see that almost the whole attack technique, almost the whole Mitre attack matrix is used by different groups. Here I only worked with one color. It was either red or white. Red means there are APT groups using that technique. White means there was no report yet that somebody used that technique. And when we see that, it's quite overwhelming. I don't know what you think, but Terry Kobe says that we can't spend 3 million euros to develop detection for all of their techniques. But I think that not every technique is used as often as another one. We want to focus now on the ones which are often used. We want to spend as less money as possible to maximize our chance to detect the attackers. In order to talk about which techniques we should focus on, I want to speak about 3 aspects. One is probability. As I already said, we want to maximize our detection chances by choosing the right techniques. I want to talk about detections. I want to introduce you to detection frameworks which contains open source detections which you can deploy already this evening in your environment. And I want to talk about log sources. Log sources then based on the detections which we choose for our defense. Okay. Let's talk about probability. What I did now, I didn't use now only red and white. I used now different shades of red in order to highlight which techniques are used very often and which techniques are very more the exotic ones. You can already see we have again the spear phishing, we have the PowerShell, we have the credential dumping. All these kind of techniques are used very often. When we focus on that ones, our chance can be higher to detect these sophisticated groups than when we focus on like very exotic ones. Let's have a look into some examples. One is brute force. Brute force has a total count of 8. Credential dumping and PowerShell has a count of 36. For me, highlighting that was very important. Because when I go to customers, when I talk with people, everybody tells me, hey, yes, I have a brute force use case. I have another brute force use case. I have a brute force use case. There's other techniques which are used more often than brute force, because brute force is very loud as an attacker. They probably try it as the last possibilities. They try to brute force something, because normally we are able to detect that. When you are curious how I did all that that mappings and the visualizations, the annotations, like this is open source. There is like this Attack Navigator project. It's like a web app which you can easily run as a Docker container. You can run it within 5 minutes. You define your own JSON file, you load it in there, and you can visualize your attacks, your defenses in the Attack Navigator as you want. You can also hover over the different techniques, and you can then add some informations what you want. So, did I now spend like a whole week clicking through the Mitre attack matrix and counting the different techniques and write it down in here? Luckily not. All the informations which you see in the Mitre attack matrix are available as cyber threat intelligence information. They have a project, you see it here. It's the Mitre CTI project, and they're using STIX2 as a description language. STIX2 is Structured Threat Intelligence Exchange format, and it defines and it contains a lot of different JSON formats, and in these JSONs are different STIX objects. STIX are different objects like what you can see here, an attack pattern, a tool, a malware, and a intrusion set, in order to describe different campaigns. They also have then relationship with each other, which means this campaign is using that malware. And what Mitre did is they mapped the different STIX2 objects to the different Mitre objects. And now, what we can do is, with a little bit Python, who's able to code a little bit in Python, or just scripting? Cool. With a little bit of Python coding, we can now develop our own scripts and going through that whole knowledge base and finding the techniques which are the most used, the software, malware, which is the most or less used, and you can write some simple functions which you probably can't read because of that beautiful beamer. With a little bit more Python coding, you can develop your own Attack Navigator overlay. You can take that data, you load it in there, you get the information of what you want, and then you put out a JSON file which is needed by the Attack Navigator, and you can visualize whatever you want. When I went to a lot of customers and talked with like SOC managers and so on, they love to talk about the Mitre attack matrix. When you visualize in the attack matrix what attacks do you see for this company or for this industry, and you can also visualize which defenses you already have in place, you have a clear picture for the management where the company is it very strong in the detection perspective, and where are the blind spots? Because before I heard a lot when we talked with SOC managers that there's a SOC manager. Yes, I'm secure. I have X, and you can substitute X with 10, 20, 50, 100 detections in my Splunk, for example. And then I ask, yeah, how did you find your detection? Yeah, we just did them. When you talk like using the Mitre attack matrix as a base, the discussion has, yeah, it's better. Let's go to detections. We found out now our priority list of techniques where we want to focus first. So now we want to find some detections. I want to introduce you 2 projects. One is like, of course, our own project, the security content. We have more than 200 Splunk detections in there. It's open source. You can download and use it as you want. It's completely free. We take analytic stories, which is, for example, analytic stories to, for example, credential dumping, and we include there detections, investigations, response searches, and also baselines. Baselines is needed for detections which are anomaly based. And then you need some kind of baseline in order to make some detections. It's in GitHub, it's open source, you can find it here, and it's mapped to the Mitre attack matrix, and it's mapped to a common information model. The common information model is like that we specified some field names and some values for different kind of information, because sometimes there's the challenge when you ingest a lot of logs from, for example, different firewall vendors, then the one field is called SLC_IP, then you have source IP, and you want to have a common field names which you can use for your detections, which is the base in order that we are able to write some detections. Let's have a look into an example. Here, because we talked a lot about credential dumping, here with that search, we are trying to detect one version of credential dumping. And in this version, we used registry.exe executable, which is available on every Windows system. And this can be used to dump the registry hive to the disk, and then they can take it away, get it out, and yes, use the secrets in there to continue their operations. There are different options to do it. There's the SAM, the registry, and the security. And do we now in Splunk know everything by ourselves, all the different attacks which is possible? No. There is an awesome project, it's called Atomic Red Team. Atomic Red Team consists of different atomics. These are different attacks which you can use for different techniques in the Mitre attack matrix. For example, now we are in the technique credential dumping. There are 12 different possibilities described as atomics. And now you can use that information to write detections for it. What we are currently working on is, this is a knowledge base. But they already have an attack execution framework. What our goal in Splunk is to spin up a small lab to perform attack simulation using that attack vectors, testing our detection, and destroy the lab again. And that in an automated fashion. This is also an open source project. You will find it as attack range. It's not on the slide, but if you're interested, we can talk later about it. Then we have Sigma. Who heard about Sigma? That's cool. Sigma is a generic and open signature format and also already containing more than 200 detections. You have the support for a lot of different theme vendors. It's not only Splunk, you have also Elastic. You can I learned yesterday that you can convert it to PowerShell. It's cool. They really focus on simplicity. They focus on that a rule is easy to read and easy to write. They mapped around 50% of all the detections are mapped to the Mitre attack matrix, and they also map it to needed log sources. Which log sources you have to have in your data platform to able to run that detection. And the workflow is like that you have a Sigma detection in a Sigma format. They use YAML for it. You convert it with a Sigma converter, and you get out your Splunk search or your Elastic search or your PowerShell query, which you can use for that to detect now the different attacks. Let's also take there an example. You see it's using YAML as a description language. It's using a lot of metadata like title, description, attacking, author. And now there is like the interesting part. We have the log source, which is like in this case, for this use case, you need Windows security logs, and you have the detection part. You have the detection part, you define one or multiple groups, and then you have the event ID. You have, in this case, you have to read it like that. Event ID is equal 517, or event ID is equals 1102. In this case, we have only one condition. We'll see in a few minutes how it looks like in Splunk then. And you have also some more metadata. This detection is trying when an attacker tries to do defense evasion. In this case, the attacker wants to clear the security logs in order that we as defender are not able to detect him anymore. When we now take that search and convert it to a Splunk query, you will have then the following. You see that part is in the detection, and this part comes from a theme-specific converter configuration file. For example, which you can adapt as you need it for your index names, source type. This is only information which is needed for a specific theme system that you can run the query. So, I did a little bit more Python coding. I like Python. What I now did, we had this mapping of detections, all these techniques used by all these APT groups, and now I use the data from these two projects, which in total have 400 plus detections, and bring it together. Like when you now hover over one of the techniques, I'm very sorry that it's so small, but you see then all the open source detections which you have available for this technique. Unfortunately, I'm not yet done with the open source process, but one question, would you like to have this kind of tool? Okay. Then I will try to open source it, finish it, and release it. You can then hover over any technique and you directly find detections which you can use for this technique. But keep in mind, you have to adapt that technique, the detections, always depending on your environment. It's never like that you can take a detection from anybody and say, okay, now this is working out of the box. It always needs some tuning from your analysts in order to make it work properly. So, now let's talk about log sources. For this example, I have to say, this is from a purely detection perspective. It's very subjective, and it's not a real company. It's again our evil corp, and you see here the mix of log sources what we have in a moment. We have like a lot of firewall logs, a little bit less Windows Server logs, proxy logs, root to switch logs, Linux server logs, and other. What I want to do now, I want to, because we have not unlimited money, we don't have unlimited space to store all that logs. That's why I want to try to reshape that log source mix in order that it fits to our detection strategy. When we take a look into the project, for firewall logs, we have less in both projects. We have less than 5% detections are detections for firewalls. When you take a look into Windows, in the Windows Server logs, where we have normally all our secrets in there, it's 50% or even more. When you take a look into proxy logs, only 15%. When we have root to switch logs, there's almost no detections for that. And Linux server logs, we have also a bunch of detections. So what I did now, and keep in mind only a detection perspective, I don't consider incident response or security operations, which wants to have that data. I shaped it like this. We now focus a lot more on our Windows servers. For example, we enabled sysmon, we enabled script block logging of PowerShell. We used a lot of more logging features from Windows servers and endpoints to now have a more amount of Windows server logs. We keep the proxy logs, and I think maybe 2 people are happy that I now added DNS logs as a log source which you should use, because they're totally right. DNS logs, there are a lot of awesome detections for it. You see a lot. What we see a lot that they use it often for data exfiltration. That's why, I don't know what was the, please monitor your DNS logs. Yes. Then we have the Linux server logs. I keep it like that, and I reduce the amount of firewall logs through through filtering, through filtering. And then we still have the other ones. Okay, here's Terry Colby again. I told him this will be in the talk. Let's talk a little bit more about the log sources. For Windows logs, normally like system application and security are normal like the standard logs. When you talk to someone and say, yeah, we collect Windows logs, then it's normally system application and security. But please enable sysmon. Sysmon brings you so much visibility in all the new attacks. You see like parent-child relations, you see registry keys, the network connections, VMI, name pipes, you see a lot. And PowerShell. Because when you have the sysmon logs, you see the command line that they execute a PowerShell script. But often it's obfuscated, and you want to know what the attacker did execute in your system. And there, I would like to highlight that you should enable PowerShell script block logging, because PowerShell script block logging is logging the event as it is executed on the system. Even when the script was obfuscated, we are still able to see what code was running, because the script logging was deobfuscated. Then we have proxy logs. There you see a lot of command and control traffic, malicious user agents, malicious URL patterns, and you often see the stage 2 payload. Normally, when they try to exploit us, there's a stage 1 malware, which is tiny, which is small. It's only used to load a bigger malware, which has all the features in there to lateral move through our environment, and so on. Which means we could see, when you use proxies, we can see the stage 2 payload. Then we have DNS logs. You see the command and control domains. You see DNS channels. You see exfiltration over DNS. we already talked about that. Then we have the Linux server logs. For Linux servers, depending on your environment, but you can get the history logs, what commands are executed. With the proper ATT configuration, you can get a lot of good alarms for it. And there is OS Query. OS Query is an open source tool developed by Facebook, which you can enable, and then you can have almost as much visibility as Sysmon on a Windows system. And then, of course, your antivirus logs. There it's always depending on how good your antivirus software is configured, but there you directly get your security alerts and your indicators. So, what we achieved now is like, we mapped a specific industry, or we can also take all APT groups, mapped it to detections, and find the right data sources for our detections. Key takeaways. Please take some time to analyze your threat landscape in order to define your detection strategy. This is very important, and you can do it. Use open source. Open source, it's free. Use open source detections. And focus on log sources based on your detections and not the other way around. Don't put everything into your log collection, your data platform, and then think about it, now which use case can I build? Do the other way around. Think about which log sources are important for detections, and then, choose then the right ones. Thank you very much.